What is passive and active insufficiency, and why should you care? More importantly, Dr. Mo with a video on some basic biomechanical muscle architecture, basic kinesiology, biomechanics information. Speaking to what I think are two important concepts when you think about how muscles operate, their force curves, and potentially how you might see regional differences in adaptation over time. So if you haven't already, please subscribe to my channel. Lots of videos on exercise, sports science, nutrition science, educational, opinion, you name it. And like this video, of course. If you like it, comment below. Okay. So I have some beautiful slides to share with you to kind of drive on this point. But to start with, just the terms active and passive insufficiency. When you think of passive, think of stretch of the muscle. When you think of active, think of a muscle that's been shortened. And you're going to see this predominantly, of course, in two joint muscles. So examples of these muscles might be rectus femoris, one of our quadricep muscles, or biceps femoris, one of our hamstring muscles. You could include all three of the hamstring muscles, of course. Biceps brachii, or upper muscle of the upper arm, the triceps even, right, can be placed in a position to manipulate the long head of the tricep. So when we're talking about active and passive insufficiency, we're thinking about how to manipulate two joint muscles in such a way that we create a stretch on one end, the proximal end or the distal end, and then create movement through the opposite end. Okay, so let me give you some examples of how this would look and why you should care, and how understanding active and passive insufficiency can also create some variety, some useful training variety in your program, because placing two joint muscles, which are typically dominant muscles in movement, in disadvantageous positions could enhance the recruitment of the other muscles that are involved with the joint's movement. So let's look at passive and active insufficiency and some examples here. So it's a typical leg extension exercise, and you can see here the person's seated. Here's their upper body, femur, tibia, shin, and then the pad in front. And so this individual is going to go ahead and do a leg extension, this awesome drawing that I produced, copyrighted. And so what's happening here is one of the muscles that we're interested in is one of the quadricep muscles, the rectus femoris, which is a two joint muscle. And so that muscle is crossing both the hip and the knee. And so by placing the hip in flexion, we've shortened the muscle. We've pre-shortened the rectus femoris. And so that muscle then should be in a insufficiency. So it should be weaker because we've placed it in this position. Now, there's 2 points here to thinking about active and passive insufficiency, in this case, active insufficiency. Neither is really supported by empirical evidence. So take this as an opinion, a very superficial look at this. And I'm not the only one that's thought of these things, but I want to make it clear there's not like a stack of literature supporting what I'm about to say. So when the rectus femoris is not in an advantageous position, it should reason then, again, that doesn't, assuming we know what happens when you assume, that the muscle's going to have to work harder in order to have the same result as it would if it was in a anatomically positioned length. So that's an optimal length, so like standing up. Okay, and I have an example of that in the next slide. So if the muscle is at a disadvantaged position, therefore it should have to work harder. It's possible then that the muscle gets, has to work in such a way that produces better gains. And it is possible that, and there's a few studies that have tried to look at this and not really conclusive so far, is that you might see differential development. So perhaps you would get more distal development of the rectus femoris as you would the more weakened proximal end. Now, it's slackened the whole muscle, and that's where we have difficulty neurologically. It's activated the same. So, that's a possibility, though, that you could get some regional development of the muscle where it had better cross-bridging than it did perhaps up in the proximal area, assuming that there's regional cross-bridging differences, okay? The second thing, what I think is a little even more plausible, is that when you position the rectus femoris in such a way in active insufficiency that it's weakened, the other musculature in the quadriceps in this case is going to have to work harder in order to produce leg extension. So, and if you look at the architecture of the muscle like the VMO, vastus medialis, the belly of the muscle is closer to the knee. And so you might get then greater development. And this is the general consensus, right? When we look at these type of exercises, you're going to get more VMO development doing these deeper, knee angles, right? And in this case, we're trying to double up and say, well, let's knock out the rectus femoris, which is a major contributor to knee extension, of course, and make that vastus medialis and lateralis work a little bit harder. And so I think that's plausible. I'm not saying that is exactly true. I'm using some of my observational observations I made over the years as well. If you look at the VMO development of Olympic style weightlifter is a little different than a power lifter, and that could have to do with the stance and just the depth of the squatting that typically occurs. You could just stretch the quadricep muscles as a whole more. So again, there's other factors here, but certainly it is possible to think that those greater knee angles are contributing to more work required by those other quadricep muscles other than the rectus femoris, because as we go into a deeper squat, it knocks out the rectus femoris. Okay. Now it probably has to do with more of the stance, because you can get a pretty good hip angle here. You can get a lot of hip flexion in a low bar squat as well when you're leaning forward. So there's a lot to be determined here, but what does this mean in terms of your training now? Well, it probably is a good idea to have some variety in your training. That's really what active and passive insufficiency is what I'm trying to get at, is that having some different postures and manipulating the two joint muscles, like the rectus femoris, like the biceps femoris, like the biceps brachii, even the triceps, right, can be beneficial in terms of trying to tap in this idea there might be some regional differences, or making some of the other muscles around the two joint muscles work harder. Okay. And this is just an example of, well, if we lean back in this leg extension exercise now, we're going to create a hip angle, right, that is approximating closer to anatomical position. And so now we're incorporating more of the rectus femoris in terms of making it less into the active insufficiency. Okay? It's more getting closer again to that optimal cross bridging that occurs. So between this first slide and this one, you could say there's more rectus and femoris just on the surface, rectus femoris optimization between the two. Okay. Let's look at a hamstring to show the same thing. Here's a prone hamstring. I haven't seen too many prone hamstring machines that are flat. And the reason is it would put the hamstring muscle hypothetically into its optimal length. And so you should be a stronger hamstring curler, prone hamstring curler in this position than what I'm going to show you next. But this would be anatomical positioning when you're laying down. You should have optimal cross bridging in the hamstrings. Now, if you look at a typical prone hamstring machine, though, you usually see some hip flexion. So you put your butt up in the air a little bit, right? That's passive insufficiency. Passive insufficiency is when you pre-stretch one end of the muscle, by manipulating one of the joints. And so in a prone hamstring curl, you have passively stretched the hamstring. You've created now a deficit in it, that muscle, that it's weakened because the cross bridges are pulled further apart. And this is, if you look at the length tension relationship, this is more of a linear decline. And the other side, it's a little more compressed because, there's only so much shortening you can do. But this is more of a linear decline. So, the more you raise your hip up, hypothetically, you have this more of a linear, right, 1-for-1 kind of ratio, if you will. I'm not saying what the 1-for-1 is, but it's more of a linear relationship. More passive flexion or more passive insufficiency you have, the less tension is going to be developed through the muscle. The potential tension, I'm not talking about active tension that can be generated by the cross bridges, not necessarily the passive tension that would occur from stretching some of the connective tissue. And so when you do this type of curl action, then you're in a weakened hamstring position. And so curling up the apparatus here, just based on passive insufficiency, you shouldn't be as strong. Now, there's other factors going on here. How the machine is constructed, the levers, moment arms, things, but just in terms of understanding active and passive insufficiency, this is what I'm getting at. This is passive insufficiency. Okay. If you do a seated hamstring curl, you're definitely now into a greater hip flexion angle. So if you think about that first slide I had when we're doing leg extension, if we did the same thing with the hamstrings, now you're doing passive insufficiency for the hamstrings. So it was active insufficiency for the quadricep, the rectus femoris specifically. Now you're in a passive insufficiency for the hamstring muscles. Okay, so it's at a deficit. We can also look at I know this is a really ugly drawing, but that's not my strength. Here's an RDL. So here's head, torso, femur, tibia, bar out in front, huge bar apparently, already into some hip flexion. Okay. And so starting an RDL movement and then going into a full RDL just below the knee. And so at an RDL, you pre-stretch you pre-shorten the hamstring by bending the knee slightly. And obviously that's done for a variety of reasons. One of them being protect the spine and help us to hip hinge better, keep the bar closer than a stiff-legged deadlift. But in so doing, you create active insufficiency in the hamstring. This exercise is compared to the prone and the seated hamstring curls. Now, the operational end, if you will, is the hip. And so because of where the exercise begins with the bar in hand and goes into an eccentric movement first, this is more of an eccentric dominant exercise. You can hold more weight, and because you're stretching the muscle initially, you're going to cause more muscle damage doing this than you would in a prone hamstring curl. That doesn't mean you couldn't, make sure you're fully elongating the hamstrings in the prone hamstring curl, and spending more time under tension. You're going to get sore doing that as well, but not like you would with the RDL. Now, one of my kind of hypotheses on this, again, people have talked about this smarter than me, but it's an interesting idea to think about. Well, if you fix this end and you rotate this end under tension, especially in eccentric exercise, are you adding sarcomeres and series over here? In other words, you're making the muscle longer here. Could you be building more of the proximal end of the muscle, less so the distal end? So where those concentric dominant exercises like the seated and prone hamstring curl may be working the musculature more around the distal end, right? It's possible that doing an exercise like this, where you're making the movable end, is where you're going to see more of the development in the musculature. I have nothing to support that in the empirical evidence. This is just an idea, just kind of piggybacking, just some interesting thoughts piggybacking off of this, what the purpose of this video is active and passive insufficiency. Now, how do you, if you put aside my hypotheses and my ideas, again, what is the value of this? What's the importance of this? Well, having exercise variety. So, RDLs are really important to protect the hamstring from hamstring injuries because it double stretches the muscle in a sense, right? So it places under eccentric loads how hamstrings usually tear, how most muscles get torn and damaged. But if you want to build the hamstring muscle in its totality, it's probably a good idea to tap in this idea of, well, I'm going to do some RDLs, which is still going to be the best way to build a hamstring because you can put a lot of stimulus into it. But I'm also going to do some leg curls too as a supplemental exercise. Just know that the leg curls will shorten the muscle because that's the nature of the exercise, and this will elongate it. Now, if you're an athlete, I wouldn't do a lot of leg curls, at least not by themselves. You could do RDLs with leg curls, just like a bodybuilder. But you probably wouldn't want to do hamstring curls alone just because it's a shortening exercise, and you can shorten the hamstring doing that type of movement, especially if you're not going to full length. Okay? I'm not saying you're going to get hurt or it's the path to injury. I'm just saying there's better ways to do things in order to protect the hamstring. Okay? So I hope this is helpful in understanding, one, the concept of active and passive insufficiency, what it means. It's a two-joint muscle issue where you stretch one end or shorten one end of the muscle at one of the joints, and that creates an insufficiency in its ability to produce force. It's a length-tension relationship at work. Well, how does that translate? Why should you care? Okay, you understand the concept, because promote some variety in your training where, if a two-joint muscle is of interest to develop, like a hamstring, then create some active and passive insufficiency in it in order to challenge it and do it at different ends of the musculature. So again, with this hamstring exercise, I can, put the hip in passive insufficiency and do some curls, or I can put the knee in active insufficiency and do some hip hinging type of activities. The variety piece can be very, very helpful. You can see the same thing with the upper body. If you did a behind the back cable curl, that's passive insufficiency at the biceps brachii. Okay. And so the biceps brachii is disadvantaged position. And you only curl at the elbow. Hypothetically, you're working more of the distal end of the muscle as compared to just a neutral stance biceps curl. If you did a preacher curl, now you put your arm over the bench, you create shoulder flexion. That's active insufficiency. And let's say that the biceps brachii now is disadvantaged. Most people can't curl as much in that position as they can when they're doing freestanding, right? And so now other muscles like the brachialis, which is only a muscle that only crosses the elbow, may have to work harder in order to pick up the slack from the biceps brachii being in a disadvantaged position. And it may be disadvantaged at different ranges of motion, okay? But having that variety in there can be helpful. We don't have a ton of literature to support what I'm telling you, but on the surface, this makes sense, and this is why variety may be helpful. Now, just because something makes sense on the surface doesn't mean it's supported. I understand all the fallacies I can get into here, but I think the importance of exercise, rotation and exercise, variety, A lot of that is nested in this understanding of active and passive insufficiency and arranging these two joint muscles. So I hope you see the value in this. It's not just some academic, vomiting on you about muscle mechanics. It's actually very interesting, and looking at machines and how they work, looking at exercise and how they work, and seeing, again, am I doing exercises that are similar? Am I putting the hamstring in passive insufficiency in 3 different exercises and not putting in active insufficiency, which may have value in some different way? That may be worth evaluating. All right. I'll see you in the next video. Again, if you like what you heard, leave a like, leave a comment. If you disagree with me, that's okay too. I've been known to be wrong before. And of course, subscribe to my channel if you'd like to hear more. The videos I'm putting out in the field of exercise, sports science, nutrition science.